Dear students, welcome to the knowledge series. Today's discussion is on operation of type 2 fuzzy set. I believe that you all have gone through my earlier video series on type 2 fuzzy set. So this is the continuations with respect to the type 2 fuzzy set. Now here you can see there are two figures which is being shown over here. The one figure is related to the type 1 fuzzy set, and you know the type 1 fuzzy set consider the membership functions as totally precise. That means it considers that there is no uncertainty appearance in the type 1 fuzzy set, and whatever the type 1 fuzzy set uncertainty that is been shown with respect to the single line, that is the inclined line, that is what been shown. When we talk about a type 2 fuzzy set, it is basically allows to handle the linguistic uncertainty. So when you talk about a linguistic uncertainty, it has to handle. So under that particular situations, it has to see that this uncertainty of the linguistic terms, it should be shown across the area about the footprint of uncertainty. So that means this entire area is been shown across the footprint of the uncertainty. So that is the shaded area, shaded areas. So here in the one side of the figure, if you try to look across the type 1 fuzzy set, if you take a particular element on the fuzzy crisp conditions, or you can take the inverse of a discourse x, in which the x is the element. Under that element you are getting the membership functions u dash. And if you take that similar situations with respect to the type 2 fuzzy set, you will find that here you will be having an infinite number of points, or a number of points you can able to see. So here at this particular figure, 3 points are shown across this particular line. So corresponding to that, if you draw the membership functions, so those values are going to reflect in the case of a type 2 fuzzy set. Now if you see this particular type 2 fuzzy set, in this one the relations, fuzziness relations plays a important role. As there is an increase in the fuzziness, that means it need to handle the inexact informations in a logical way. So that is what, the more the fuzziness, then the corrections of that one need to be handled in a logical manner. So that is what we see in this particular figure. Now when we go further to the next figure with respect to input and antecedent operations, here if you try to see that, you assume that this is a one fuzzy set A and this is another fuzzy set B. So and there is another two fuzziness is been shown, or we can take into consideration that for a single fuzzy under the two situations, that means on the one side of the fuzzies, left side of that type 2 fuzzy set, you are getting a membership functions, right side you are getting another membership functions. In the similar way, if you try to take that two operations, that means the operations with respect to the minimum minimum membership function, or that is nothing but a lower membership function, and the upper membership functions, its minimum. If you are taking that one into considerations, you will be able to put that one into an operations. The similar way you can take a product operations with respect to the two different sets of membership functions. under the type 2 fuzzy set, because in the type 2 fuzzy set you will be coming across a number of points, but in the type 1 fuzzy set, since it is a single point, that particular minimum operations you no need to take under the single set. But if it is a more than one set, you can take into consideration. So here, in the case of antecedent operations under the type 2 fuzzy set, you have to take into considerations these factors. Wherever the intersection point comes and its corresponding membership function generates, its minimum operations has to be take for the lower membership functions and the upper membership functions. Now let's see the another discussions with respect to the interval of the type 2 fuzzy set. Now under these particular conditions, if you try to look across, here you will be finding that one side it talks about the fuzziness of the type 2 fuzzy set, and where you are having the membership functions at the at 1, it is having a flat surface. So under the flat surface, you will be able to see that if you take a distributions, it will be more or less having a range under the Gaussian membership functions 4.5 to 5.5 as per this figure. So but on the other hand, if you take the next figure, here you have to go for the variance, because the membership functions here and under this particular figure, you will be finding that more amount of a variance exists as compared to the upper figure, because here when the membership function is equal to 1, you are getting a flat surface over, whereas here you are having a direct peak surface, peak or the peak period is coming. So at the peak point, you will be getting a membership function is equal to 1. So this is another way into representing the membership functions. But here one thing you have to understand is that variance in this case will be more. So variance is more, and the Gaussian membership functions, that variance, whatever it has been showing over here, it represents that it is a area with respect to uncertainty. So Dr. Zade was working on this particular area, and later on several people has put across this work into a further extension, and they tried to publish several set of papers that can be useful for the future researchers. Now coming to the operation of a type 2 fuzzy set. Now in this case, if you look across the type 2 fuzzy set operation, in the here it is mentioned that A and B is the two sets, and this has to be put under the type 2 fuzzy set, and since this is considered as a type 2 fuzzy set, if it has to put under the type 2 conditions, the operation of the type 2 fuzzy set under this 2 set, it is being represented as a fuzzy set A is equal to x comma mu A of x, and B comma fuzzy set B is equal to s comma mu B of x. But here if you simply see, it is looking like a type 1, and you know the type 2 is the extension of the type 1, and its mathematical modeling is from the type 1 fuzzy set. So here this mu A of x is further extended. Mu A of x is nothing but it is u of I comma mu u of I of x, where x is belongs to capital X, that is the universe of a discourse, and u of I and mu u of I belongs to the range is 0 to 1. Now the another set mu B of x, it is being defined V of j comma mu V of j of x, such that x belongs to capital X, and V of j comma mu V of j ranges between 0 to 1, that belongs to 0 to 1. Now here we have to apply the extension principle, because the extension principle was developed by Dr. Zade way back in 1975 to enable the domain of a functions on fuzzy sets. So it generalizes a point-to-point mapping. That is what when we take a two fuzzy set, so and defined by the single universe of a discourse, like here you see fuzzy set A and fuzzy set B under the universe of a discourse X. Here, based on that conditions, that extension principle is applied. Now here, if you try to see under the extension principle, the first condition is the intersections, because this is what we are discussing on the operations. So when we combine these two equations, that is mu A intersection B, fuzzy set A, and the intersection fuzzy set B of X, where X is the part of the universe of discourse, capital X. So mu A of X intersection mu B of X, that is defined as W, comma mu A A fuzzy set A intersection fuzzy set B of W, such that W is the minimum of Uj and Vj. So what is W? Now if you see that W, this W is the weight. So mu A of A intersection B of W, that means these sections, that is nothing but supreme and its minimum of mu Uj comma mu Vj. So it's a supreme. Supreme means, say for example, it talks about the least upper bound. Suppose a line is the maximum line. Its upper bound. What is the least upper bound? So whichever value is there, it's a minimum, and its maximum value is nothing but the least upper bound. And this is basically, if you look across the bottom side, the smallest quantity that is greater than or equal to each of the given set and subset of quantity, the least upper bound is of each given set. That means you have a collection of set. In that, whatever is the minimum sets, among the minimum set, which is the maximum highest one. So that is how it is looking for. So it looks for the supreme of minimum of mu Vj and u Vj and mu Vj. Now what is W? W is nothing but minimum of Ui and Uj. So that is what the minimum operation. This is talks about the particular sets, and this is talks about the membership functions representations. So this is represented in terms of these notations, and this is represented in terms of this notations functions. These both are functions. Now if you look across the maximum side, that is union mu A union B of X in the type 2 fuzzy set, mu A of X union mu B of X. So that is equal to W comma mu A union B of W, and W is equal to maximum Uj comma Vj. So here where this is nothing but again a supreme minimum of mu Uj and Uj. This is a minimum operation and its highest value, but W remains here. What? But W changes here to maximum of Uj Vj. So that is how we have to look across to solve this particular problem. Now let's see this numerical problem with respect to the intersections. That is given as set A, set B. Find the A intersection B of a membership function of type 2 fuzzy set at X is equal to 3. So that is what it has been termed, X is equal to 3. That means it has a at this instant you are having a 3-dimensional values. So crisp element where the fuzzy set A is a set of is a function of Uj and mu Uj, and B bar fuzzy set is a function of Vj and mu Vj. So this is the table is given. I is equal to 1, 2, 3, uj is given and vj is given for a two different set. Its membership functions is given and its membership function is given at say at x is equal to 3. To solve this one, first of all, let us rewrite this one in terms of a bar. A fuzzy set a bar is equal to x comma mu a of x. That means this value and this value. So if you try to see this one, so it is a 0.8 comma 1, 0.7 comma 5, 0.6 comma 4. That is what it has been written. Second is mu b of x, that is at 3. So here as again you can see here it is between v and mu v of j at 3. So 1, 1, 0.8, 0.5, 0.7, 0.3. That is what we have seen here. Now from these two memberships, we have to find the intersections. That is what we are seeing in this here. So we have to find the intersection of this one. That is a minimum operations. And then similarly we have to also see that its supreme also we have to find. So how to do this one? So we will go with the further table extension. What we do is that now we are mapping this 0.8, 0.7, 0.6 to these values. That means 0.8 to these three values, 0.7 to these three values, 0.5 to these three values. So once we do this one, similarly we also try to see this membership also mapping to from 1 to these 3, 0.5 to these 3, 0.4 to these 3. That is what we are seeing here in this table. So here when we try to see here 1 to 0.8 0.8 to 1 1.87, and here 0.7 to 1.1 0.8 0.7 0.6 to 1 0.0.7. Among this one we are finding its minimum value. So these two minimum value 0.8, 0.8, 0.7, 0.7, 0.7, 0.7, 0.6, 0.6, 0.6. So we have got the minimum of these two. Okay. Now the next is what we are going to find these two values after writing the mapping. Here also we are going to find the minimum operation. This we have got it from where? The same way I told that this one is to map with these three values 1 to 1, 0.5, 0.3, 0.5 to 1, 0.5, 0.3, similarly 0.4 also. That is what I have written here. Here also we are going to find the minimum. So here minimum, 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 minimum. So you got this value. Now once you got this value, the next stage is that you have to find the supreme. Now you have to understand that before we find this particular supreme, we have to make the arrangement with respect to the grouping. Here there are three groups. The 0.8 is one set of group, 0.7, 0.6. This is 0.7. Okay, 0.7 has been mentioned there. So 0.8 group these two, 0.7 is this 4 group, 0.6 is 3 group. So with respect to that, we have to map with 1.5, and for these 4 group, this 4 group is taken, 4.6 point this one. So we are taking a supreme of 0.8. Supreme of 0.8 means we have already taken the minimum operation, its maximum operations. So that means among this one the highest one, that is 1. Then among 0.7 supreme with a weight of 0.7, we are going to find from here. So its highest, the largest one or the upper bound is nothing but 0.5, the largest value. Now when we talk about a 0.6, here with respect to these three values, we are taking the highest value, that is 0.5, 4. So this is what we have got, 3 value. So here I mentioned that now we are having this set of values in this line, a values A, B, like that. So we are the supreme means among this one the smallest value, and in that smallest value which is the high the maximum value. So we try to select the region, and we got it, assume that this one. So this is known as the upper bound among these values. That is what supreme of A is the least supreme of A is the least upper bound of the set A. This is the given set of elements A. All other upper bounds are larger than supreme A. So anything which is among the minimum, the highest value, that is considered as the supreme. All other are values we are ignoring. So here we got three values, 1, 0.5 and 0.4. So for a weight W comma 1, 0.7 comma 0.5, 0.6 comma 0.4. What are these three values? You know that these are the three values with respect to A intersection B, mu A intersection B. That is what we see. And what is weight W? 3. That means you are having a 3 points at this particular 3 points means you are having in the your point of intersection 3 places will be there, so it will be having 3 values, and that 3 value is how you are knowing when whenever the 3 values appears on the footprint of uncertainty. So that I have already explained in my this W is there in my first first video and second video of the fuzzy set 2. Now let's see the union operations. When we talk about union operations, what we have to do, it is the same things. These portions remain same. E of I, V of j, mu u of I, mu v of j, it remains same. Here what we have to do, we have to do maximum operations. Here we have to do particularly the maximum operation. Why maximum operation? Because it's a part of a W. That is what we term it. And here it remains the same minimum operation. So when you try to do this, in this case maximum operations, you will be getting the different values. So like here 1.8, this is 0.8, 1, 0.8, 0.9, 1, 0.8, 0.7. Like that you will be saying getting the values. So once you get these values, from these values you have to group it, whichever is in the group 1, whichever is in the group 8, whichever is in the group 7, like that you group it, and based on that particular grouping you have to see that whichever is now let me take a 1 is having 1 here, another one is 0.5, another one is 0.4. So you are having these 3 conditions. So among this one which is coming, 0.4 is there, 0.5 is there, 1 is there. So that one is coming as 1. Among this one which is 1, which is larger, it is 1. So under the case with respect to 0.8, 0.7, 0.6, you have to find with respect to that particular conditions. But so here for the 1 you are getting 0.6. So you, no, 1 you are getting 1. Like that you have to identify these 3 cases. So that's how this union operation take place. So this is the similarly just like how we have done here, supreme case, minimum already done it, its maximum. So this will also vary correspondingly. You can see these values, and here this value has a certain resemblance you will be seeing almost all, but almost all it will be closest your value. So here in this case, means we have got the same values, but automatically this value remains same in this particular aspect. So you will be getting the value related to this the A union B in the case of a type 2 fuzzy set. Now finally we try to see the fuzzy logic systems. Now what the fuzzy logic system? The fuzzy logic system in the type 1 fuzzy set, we are having a fuzzifier, we are having a defuzzifier, inference rules. But in a type 2 fuzzy set, which is being wide accepted because of the because of its improvement in handling the uncertainty. So the block diagram of a type 2 fuzzy set, when you try to look across, it consists of a fuzzifier. Crisp input is given. after falsifier it produces a fuzzy input, and in the fuzzy input it will try to produce a membership, and that membership is being grouped as per the rules, and that rule is given applied to the inference, where inference will try to map between the rules and the fuzzy inputs, and thereby it produces a fuzzy output. And this second section is a type 2 fuzzy set. So this is a type 1 fuzzy set. So type 2 fuzzy set, it will try to reduce the set of the type 1 fuzzy set, then applying the basic conditions with respect to the weight, and there how the type 2 fuzzy set applies the logic, and then it will apply to the defuzzifier, and then the crisp output is being generated. Hence, when you try to see the type 2 fuzzy set, though the complexity has increased, but type 2 fuzzy set also gives apply for the applications where just like image processing, in the computer vision, video processing, robotics, and many advanced systems, type 2 fuzzy set is being put together. So this covers the basic discussions related to the operations on type 2 fuzzy set. With this, I conclude here. Thank you.